All right, बच्चों अस्सलाम वालेकुम. So we are doing IGCSE chemistry P6, that is alternate to practical. We're doing paper 6 variant 2 2024 October November. All right, let's look at the first experiment. All right, let's look at the first experiment. A teacher uses the apparatus shown in figure 1.1 to pass an electric current through molten mercury to bromide at a temperature of 300 degrees Celsius. All right, here's the power supply. Here are the electrodes. Here is A, here is ice. All right. During the process shown in figure 1.1, the molten mercury to bromide breaks down and forms bromine and mercury. Table 1.1 shows some information about mercury to bromide, bromine, and mercury. All right. Uh, Experiment substance, mercury to bromide, melting point 236, boiling point 322. Okay, bromine and mercury. Okay, draw an arrow in figure 1.1 where the apparatus should be heated. All right, so they continuously ask us for where the apparatus should be heated every time, right? So the question is, okay, pass an electric current through molten mercury bromide at a temperature of 300. So mercury bromide should be heated up to 300 degrees Celsius. Where is mercury bromide? Right here. So this should be the arrow where mercury bromide should be heated. All right. So we'll draw this arrow right here. Okay. This is where mercury bromide should be heated. Next question. Name the item of apparatus labeled A. A is a test tube. All right. Test tube, right? As you guys can see, this is our test tube. All right. Next question. Name the process shown in figure 1.1 which breaks down mercury to bromide. Because of electricity, mercury bromide is being broken down, right? So that process is called electrolysis. Electrolysis. All right. Next question. The electrodes used in process shown in figure 1.1 are made from platinum. Give two reasons why platinum is a suitable material for electrodes. One, it is a good conductor of electricity. It is a good conductor of electricity. And two, it is inert. The most important thing is that it is inert, unreactive. All right, it does not react. There is also one more that you can say, look, because electrolysis requires heating up, molten substances are involved, so you need a electrode with high melting boiling point. Platinum has high melting boiling point as well. All right, on figure 1.1, draw an X to show where mercury will collect. So where should mercury be collected? So because these are the two electrodes and this negative one is the cathode, right? This is the cathode, right? So we want to draw X where mercury will be collected. uh, so mercury, it will obviously be collected near the cathode. It will obviously be collected near the cathode, right? So this is where you want to draw X, all right? Because at cathode, mercury will discharge, and at anode, or whatever the other one was, bromine, yeah, bromine will form at anode and leave. Next question. Explain why ice is used in an experiment. Why do we use ice? Because the bromine vapor that comes is going to liquefy and get collected over here, right? So bromine,
To
so that
like
bromine, yeah,
condensation.
so that bromine vapor can be condensed. So that bromine vapor can be condensed. All right, on to the next question then. Question number 2. A student investigates the rate of reaction between aqueous iron 3 nitrate and aqueous sodium thiosulfate. I am shocked. Because it is of 2024, we had that variant 1. It had the same type of question, but it's not exactly the same question. Let's look at this question then. Student investigates the rate of reaction between aqueous iron 3 nitrate and aqueous thiosulfate. The student does 5 experiments using apparatus. All right. Once again, we are not really going to read the whole experiments, but let's look. Volume of aqueous sodium thiosulfate added every time. All right. So volume of aqueous sodium thiosulfate that is added every time.
It looks like the beaker is on a marking scheme.
The beaker is on a
Marking scheme.
oh yeah, on the question paper. That's what it looks like.
Yeah.
So he added sodium thiosulfate, um, and he did 5 experiments, and here is the time. The funny thing is actually this sodium thiosulfate question, a very similar question like this has appeared in a paper that I have recently done for you guys. I think it was 2024. Was it 2024 October number? No. It was, I think, 2023 variant 2. I think 2023 variant 2. Yeah, right here. Look, this exact same question has come in October, May, June 2023, and then it has been repeated in October, November 2024. You can see this question, right? So this is actually crazy with different values though. So it means that in paper 6 questions can be repeated. All right. But anyways, well, we have to tell what volumes of sodium thiosulfate have been added. So in the first one, we are adding 15 centimeter cube of sodium thiosulfate. In the second one, we are adding 10 centimeter cube. In the third one, we are adding 7, 6, and 5. So let's write all those values down. 15.0, 10.0, 7.0, and then I forgot what are the other two, 6.0 and 5.0. 6.0 and 5.0. And the time to see the text that is beneath. Basically, beta, the whole experiment I'll explain to you so that you understand well. Beneath this is a set of writing. In this one right now, when you add sodium thiosulfate, the sodium thiosulfate is going to make this water cloudy, okay, blurry. So you won't be able to see the text. But then iron 3 nitrate will react with sodium thiosulfate and the solution will become clear again and you will be able to read. So you want to see how long it takes for you to be able to read again what is written beneath the beaker. That's going to basically show you the rate of reaction. All right. So now let's measure the time. So for the first moment, the smaller hand is for the minutes, as you can see, and the larger hand is for the seconds. As you can see in the stopwatch, at 0 minutes and 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So at 0 minutes, 24 seconds, meaning just 24 seconds, um, we see the we have it visible. All right. At if we add 10 centimeter cube of sodium thiosulfate, the rate of reaction is going to be slowed down. And how long will it take? 0 minutes and so this is 45, 46, 47, 48, 49, 50, 51 seconds. All right. So this one will
Wait,
be
sir,
51
don't
seconds.
write S. Don't write S.
Why?
It's already up there.
Oh, yeah, it is. So we can just write 24 and 51. Sure. All right. And
Which means all
in fact,
all of them have to be in seconds.
yeah, they are all seconds right now.
Hmm.
We can put a 0.0 in front of it if we want. Okay. Next we have 1 minute and after 1 minute, how many seconds? 1, 2, 3, 4. So 1 minute and 4 seconds. 1 minute.
64.
Yeah, 1 minute and 4 seconds. 1 minute and 4 seconds. That is equals to 60 plus 4. This is equals to 64. This is how many seconds are required. 64.0 in fact, because we've done up to 3 decimal place. Why not? All right. And then we have 1 minute again and 30, 31, 32, 33, 34, 35, 36, 37, 38. So this is 38. So it is 1 minute
98?
and 38 seconds. All right. So it would be 60 minutes and 38 seconds combined. So that would be
98.
98 seconds. All right. Next, we have 1 minute and How many seconds is that? That is 45, that is 50, 55, 56, 57, 58. So that is 1 minute 58 seconds. 1 minute 58 seconds means 60 seconds plus 58 seconds. That should be equal to
118.
118 seconds. All right. So this is how you fill out this whole table. Pretty easy. All right. Pretty easy. Um,
Are you allowed to do working in there?
I mean, why should you not be? You can do working as much as you want, okay? Just have the answer clearly visible. Your final answer should be clearly visible. All right. Next question. They want you to label the axis, the y-axis once again. The x-axis have been labeled. All right. So the time is going from 0 seconds to 118 seconds. So we can go from 0, 20, 40, 60, 80, 100 and 120. Absolutely we can. 120, 100, 80, 60, 40, 20. All right. 120, 100, 80, 60, 40 and 20. Okay. After that, after that, we want to plot the graph. So the time is against the volume of sodium thiosulfate. So let's suppose at when the volume of sodium thiosulfate is 5.0, the time is 118. So when the volume is 5.0 right here, look, 5.0, the volume is 118. So 118 should be this value, right? Okay, 118 should be this value. Next, we have when the 6.0, the value is 98 seconds. 6.0, the value is 98 seconds. 98 seconds should be right here. Now, how do I know that this is 98, this is 118? Beta, if you look at this, between 100 and 120, how many boxes are there? Between 120 and 100, how many boxes are there? You can count, there are 10 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? There are 10 boxes. And 100 and 120, the distance between them two is 20. That means each box, one box is equal to two values. Meaning this is 102, this is 104, this is 106, this is 108, this is 110, then 112, then 114, then 116, then 118, and 120 finally. All right. So you should know how to plot a graph. All right. I mean, there should be no hesitation in understanding how to determine what set of values you would have to have. So this value was exactly 118 at the second last box of the graph. That is something I established by just looking at the graph. And similarly, this should be 98 because just 2 less than 100 is 98. That means one box below 100. All right. Let's look at the next value at 7 centimeter cube. The value is 64. So at 7.0, the value is 64. So this is 60, 62, 64 should be right here. This is what 64 should be. Okay. Next we have at 7, after 7 it is 10. At 10 centimeter cube, the time taken is 51. At 10 centimeter cube, the time taken is 51. So this is beta 50 right here. This is 50 and this is 52, right? So 51 would be between them. So meaning at 10 centimeter cube between 50 and 51, we are going to draw a line. Okay. And then next, sorry, can you repeat? But I did not hear you. Are you saying something?
No, sir.
All right. And when we add in 15 centimeter cube of sodium thiosulfate, the time taken is 24 seconds. So let's just add 15. This is 15.0. And at 24 seconds, so 15.0, this is 20, 21, 22, and this should be 24. All right. So this is our value 24. All right. And then what has the question asked? Because these values are very spread out. Draw a smooth curve of best fit. So we have to draw a smooth curve of best fit. This is the smooth curve of best fit. If you observe, we have omitted this value because otherwise the curve could not have been smooth. That just looks very wrong. The 64 value, it looks very wrong. All right. So let's just leave.
Anomaly?
Yeah, let's just leave that for an anomaly. Now let's look at the next question. State why the contents of beaker are stirred after adding the aqueous sodium thiosulfate to the aqueous iron 2 nitrate. Why are they stirred? So that reactants are evenly mixed. So that reactants are properly mixed. Properly mixed, all right? So that reactants are properly mixed. Next question. Deduce which experiment has the highest rate of reaction, the one that takes the least time, the who takes the least time, experiment 1. So here you want to answer experiment 1. Next question. Use your graph in figure 2.2 to predict the time taken for text to become visible if volume of aqueous sodium thiosulfate is 12.5 centimeter cube. Show your working on figure 2.2. So if the volume is 12.5 centimeter cube, so this is 12 and this is 13.0. 12.5 would be exactly in between them. So this should be 12.5. So what you have to do is, first of all, make it red because I am trying to do a question. 12.5. All right, we're going to go up. All right, and then we're going to go. So this is our value. This is going to be after 30, 30, 32, 34. This is 36. All right. So the time taken should be 36 seconds. 36 seconds. All right. Next question. Explain why it would be an improvement to measure the volumes of aqueous iron 3 nitrate in the burette rather than in the measuring cylinder, because burette has a higher degree of accuracy. That is always what you have to write if they ask why burette is better than measuring cylinder. Burette has a higher degree of accuracy. Accuracy. All right. Next question. Explain why it is not possible to use a volumetric pipette to measure the volumes of aqueous sodium thiosulfate used in experiments. Beta, if you look at the experiments, what had they said? They had said that you are using a 25 centimeter cube measure a cylinder to pour 15 centimeter cube of sodium thiosulfate into the beaker. At the same time, start the stopwatch. A pipette or a burette, if you use to add sodium thiosulfate in the nitrate guy, it would happen drop by drop. The reaction would start before all of it has been added. So when would you stop the start watch? When would you start the stopwatch? You wouldn't have an accurate answer for the time taken, right? So measuring cylinder is good because it is faster. All right, adding it through a pipette is slower, and the reaction would begin even before all the sodium thiosulfate has been transferred. The reaction.
There also like in the other paper that we did, can we say that the volume isn't the same in each experiment?
We could say the volume is not the same. The volume of sodium thiosulfate is changing. That is also a reason why we could we could say that because the volume is not the same, we have to use a measuring center. That is also true. All right, that could be as well. The reaction would begin even before all the reactant has been transferred from the pipette. Reactant has been transferred to the pipette. All right, and we could also that is also true. We could say that the volume is not similar. The volume is not similar. Volume is constantly changing. You'll have to use different set of pipettes to measure these volumes. All right. Next question. Describe how the reliability of the results of this investigation can be checked. How could they
Repeating the
be checked? Very good.
experiment and comparing the results.
Very good.
Taking the
Repeating,
average.
repeating the experiment with same volumes. Same volume and comparing the results. Next, describe how the results of experiment would change if experiment are repeated using a narrower and taller beaker. If the beaker is narrow and tall, that means there is more liquid, right? There is more liquid, so it would become harder to see. I mean, the liquid would be unclear for a longer period of time, right? That is what happens, right? Like, for example, take a jug, all right, and take a glass, all right, because glass has a smaller width or it is not as wide as the jug. The juice in the glass looks very dark. Pour the same juice in the jug because it fills a larger surface area beaker or container. So you will see that the jug, inside the jug, the juice looks a little lighter in color. So if you use a narrower and taller beaker, the colors would be more dense, or color would be more yeah, dense, and it would be difficult to observe it faster. I mean, time taken to
The
observe
printed
the
text.
color, yeah, time taken to observe the printed text would be longer,
Be
right?
longer.
So
Yeah.
time taken to see the printed text, see the text would increase. All right. Next explanation, because as beaker is narrower,
So, as with one S.
what?
As with
Oh,
one S.
sorry. As beaker is narrower, the color will be darker. The color will be darker. Describe additional measurements that must be taken to determine whether the reaction in this investigation is exothermic or endothermic. We use a thermometer to check if temperature has increased or decreased. Use a thermometer to check whether temperature has increased or decreased. Has increased or decreased. Full stop. All right, guys, on to the next question then. Tests are done on two solids, M and M, M and N, M and N. Table 3.1 shows the test and the student's observation for solid M. So here's the solid M, and he does a flame color, and it's lilac, which means it is potassium, right? K plus, okay? And then he dissolves the rest of M in water, and he divides solution into four portions. The first portion, he adds 1 centimeter cube of dilute nitric acid and silver nitrate, and a cream precipitate forms. Therefore, it must contain
Bromide.
bromide ions. All right. Then he does the second thing. He adds to the portion of M sodium hydroxide, and then in excess, and the green precipitate forms, which the precipitate remains when excess sodium hydroxide is added. So green precipitate forms, that is confirmation that it is Fe plus 2 or Cr plus 3. But because the precipitate does not dissolve, it remains. That means it is not chromium, it is Fe3 plus, right?
Yes, sir.
Okay.
Wait.
Next, yeah.
But it says Fe2 plus is soluble, is
Who
insoluble as
says?
well.
Is who? Is?
Insoluble. Wait, is this sodium hydro? Oh, okay, my bad. So yes, yeah.
Okay. Next, to the third portion of solution M, add 1 centimeter cube of aqueous sodium hydroxide and a small square of aluminum foil. Warm the mixture and test any gas produced. Damp red litmus paper. Red litmus paper remains red. That means nitrate is absent. NO3 minus is absent. That is what they have tested for. They tested for the presence of nitrate. They added sodium hydroxide, they added aluminum foil, they heated. If NO3 minus was there, then ammonia gas would have produced, which would have turned the litmus paper blue. But because the litmus paper did not turn blue, it means the nitrate ion is not there. Understand?
Yes.
Then he adds to the fourth portion of solution M 1 centimeter cube of nitric acid, and then he adds aqueous barium nitrate, and he sees a white precipitate. That means there is SO4 minus 2 present as well. So this guy is present, this guy is present, this guy is present, and this guy is present. So now next question, explain why a
Sir, can you
yellow,
explain the test 4 again?
the test for who?
Test 4.
The problem is over here that you guys have to accept. First of all, Dekho, I will not explain the test. First I will explain to you that it's not necessary that every time a positive result comes, you should know what test is done for what ion, what gas, and what flame test is done as well, right? Now for example, test 4 says they added 1 centimeter cube of sodium hydroxide, then they added aluminum foil, and they warmed the mixture, right? For whom is this test done? If you go down here and look in the anions, you look at the nitrate anion, right? You see sodium hydroxide, aluminum foil, and warm carefully, right? So who's the test done for? The test is done for nitrate. And what is the confirmation of test? That ammonia is produced. Now, if ammonia is produced, it turns the red litmus paper blue. Okay. Now, think of all these things simultaneously in your brain and read this question now, that after this test was done, the litmus paper did not turn blue. That means there was no ammonia formed. If no ammonia formed, that means nitrate must not be present, because this is now a negative result. Understand?
Yeah. So isn't
Every time
ammonia a compound, not an ion?
ammonia is a gas,
Yeah, but why did you write NO3 minus?
who is this test for?
Yeah, I know ammonia. I'm just
Nahi.
generally asking, isn't ammonia just
Nahi,
NO3?
this is not what is this test for?
Like the
This is for
ion.
nitrates. Oh, okay,
who is
guys.
this test for?
It's for nitrate.
It's for nitrate, right?
NO3,
During this
yeah.
test, ammonia gas is produced that confirms nitrate, right?
Yeah.
Ammonia is Ali
Yes.
base.
Right
So it
now,
Ammonia
turns
is not
blue.
there, so that means nitrates are not there. So
yeah, ammonia is absent. Yeah,
yes.
we can say ammonia is not produced. This litmus paper staying red confirms it. And that is
Yeah.
why we say that nitrates are absent. Okay.
Absent. Yes.
Next question, explain why a yellow safety Bunsen burner flame is not suitable for flame test. Because yellow color will interact or interfere with the color
Mask.
produced, right? Yeah, mask, good word. So we will say that yellow flame masks. So yellow flame may mask the real flame color. May mask or conceal भी बोल सकते हैं, or conceal the flame color produced by the ions. Flame color produced by the ions. Full stop. Next question. Identify the 4 ions of solid N. Well, we have. So they are K plus, Br minus, Fe2 plus, and SO4 minus 2. So M contains potassium ion, K plus, and then after K plus we confirmed bromide ion, bromide Br minus, right? And then it contains also iron Fe2 plus, iron 2 ion, Fe plus 2, and sulfate ion. So 4 minus 2. First one. Next question. Test on N. N is ammonium carbonate. Record the expected observation. The student transfers approximately half of N to a boiling tube and add 10 centimeter cube of sulfuric acid. Any gas produced is tested. When they say any gas produced is tested, it means you can't say that when ammonium carbonate reacts with sulfuric acid, it produces carbon dioxide. No, you will say effervescence of a colorless gas, SCNC, effervescence of a colorless gas which turns lime water milky. This is how you're going to say. You're not going to say carbon dioxide gas is produced, even though you know, because it is a carbonate and because sulfuric acid is reacting, when acid reacts with carbonates, it produces carbon dioxide. You
Yeah,
know that.
salt plus water plus carbon
Yeah,
dioxide.
but the carbon dioxide that is produced is colorless. And it's not being produced and it's screaming that I am carbon dioxide. So you can't really identify it without its test. So you have to test it. Okay. Next, the student dissolves the remaining solid N in water to form solution N. Solution N is divided into two portions. All right. So the ammonium carbonate is dissolved and into two portions. The first portion, student adds about 2 centimeter cube of sodium hydroxide and gently warms the mixture. Any gas produced is tested. So because it contained the ammonium ion, adding sodium hydroxide and warming would produce ammonia gas. If you don't
Ammonia.
believe me, we don't know that. Let's look at this ammonium ion. Anywhere ammonium ion is present, when you add sodium hydroxide, ammonia gas is produced on warming. All right. So you will say that colorless gas produced which turns damp red litmus paper blue, red litmus paper blue, full stop. That is the test. On to the next, to the second portion of solution, and the student adds excess aqueous ammonia. Now let's go and look for the test for ammonia. Any cation ammonium ion, does it do anything? No, there is no result, right? No result for aqueous ammonia when aqueous ammonia is added in an ammonium solution, right? So we will say no change. No change occurs because of that. All right, no change occurs. OCC URS occurs. Full stop. All right, next question. Limes and lemons are citrus fruits which contain aqueous citric acid in their juice. Citric acid reacts with alkalis such as aqueous sodium hydroxide. Plan an investigation to find which of lime juice and lemon juice contains the most concentrated aqueous citric acid. Assume that citric acid is the only acid present in the juices. All right, your plan must include the method to use, how the results are used to determine which juice contains the most concentrated aqueous citric acid.
Wait,
You are
sir, does
provided
this
with
mean? Okay, sorry. I was
does
gonna
this
say,
mean
is
what?
this that we're gonna have to do titration twice?
We are going to have to do titration, yeah, at least twice. I mean, one for the lemon juice and one for the lime juice. Okay, so wherever you want to find out concentration of something, that is the definition of titration, right? Finding out unknown concentration using known concentration. All right. So you're going to take the lemon juice and you're going to take the lime juice of equal weight, right? Or basically, even better, you're going to say take equal volume of lemon juice squeezed from pure lemons and equal volume of lime juice squeezed from pure lime, and take 1 molar या फिर 0.5 molar mole per dm cube aqueous sodium hydroxide in a beaker, and 25 centimeter cube of lime juice in one beaker and 25 centimeter cube of lemon juice in one beaker. Add a suitable indicator. A suitable indicator could be, because lime juice and lemon juice have citric acid. Citric acid is not the strongest acid. So actually use an indicator that supports a strong alkali. And who supports strong alkali? Thymophthalene, right? So we will add thymophthalene, all right? So add a suitable indicator such as thymophthalene. Once you add thymophthalene, then start titrating the two and find out the volume required volume of sodium hydroxide required to neutralize 25 centimeter cube of lime juice and to neutralize 25 centimeter cube of lemon juice. The volume, the one which requires more volume of sodium hydroxide to be neutralized is the more concentrated one. Does that make sense to you guys?
Yeah.
Yes.
All right. So now we just have to go ahead and answer the whole thing in our own words. So we are going to say, what are we provided with? We are provided with the juices. All right. So we'll say, take a beaker.
And sodium hydroxide.
No, not sodium hydroxide.
No,
We are not. We have
No, I
sodium
mean it's
hydroxide.
provided.
It's provided to us. Yeah. So first, take a beaker and add 25 centimeter cube of AQUEOU. No. Right now, lime juice. All right. First, let's take lime juice. All right. So, okay, in a beaker. Now, take a burette and fill it with aqueous sodium hydroxide. Full stop. Mark the initial reading. Yeah, note the initial reading on the burette. Note the initial BURETTE burette reading. Full stop. ठीक है? Add a suitable indicator in lime juice. Add a suitable indicator. Add few drops of suitable indicator.
Sir,
Add
will the
few.
thingy work if we just like switch it, like in the beaker we add the sodium hydroxide and in the burette we add the lime juice? Is that okay also or no?
That is perfectly fine as well. You are going to need to use methyl orange then. All right. Or you can use phenolphthalein as thymophthalene as well. It's not really that big of a deal. You can use both of them. Yeah, over there, then you are going to see that if, let's suppose, hypothetically speaking, I do not know. Okay. If lime juice is more concentrated than lemon juice, then less lime juice would be required to neutralize the sodium hydroxide in the beaker. If we use sodium hydroxide in the beaker, right? Okay.
Oh, so it's better we do it this way.
No, both ways are fine.
It's
Add
just that
few
your
drops of-
result will vary. So it's like if you have the acid in the burette, then it's whichever acid you like less volume of acid is used is the one that's the more concentrated one.
less volume of alkali used is the more concentrated juice, because juice contains the acid. All right. Dekho,
Yeah.
the answer is going to vary only on the basis of how you perform the experiment, right? Both ways are absolutely correct. All right. I like to use sodium hydroxide in the burette because then I'll just say, okay, the one which requires more sodium hydroxide is the more concentrated one. Full stop. That is it. All right. Next
Yeah.
question.
Okay.
Add few drops of suitable indicators such as thymophthalene. Phthalene, full stop. ठीक है. Uh, Start titrating the sodium hydroxide with lime juice, drop by drop, while swirling the conical flask. All right, yeah, okay. So in the beginning, I wrote take a beaker, but I like to swirl the conical flask, right? Conical flasks are better to swirl. Do you know why? Because they have a small neck, small mouth, right? So when you're swirling, there is less chance of the acid splashing out of the apparatus, out of the flask. But beaker, they have a fat mouth, right? So splashing out of the beaker is very common, right? So we take a conical flask.
Sir, can I say measure 25 cm cube of lime juice and then add it to a conical flask?
Yeah, you can say measure 25 centimeter cube of lime juice using a pipette and add it to a conical flask. You can say that. That is better, adding information. All right. So the more information you can add, the better. All right. While swirling the conical flask. All right. Observe the endpoint by seeing the color of indicator change. So stop titrating and record the final volume of aqueous sodium hydroxide required. या फिर ऐसे नहीं. Let's write record the final volume on the burette. So stop. Subtract the initial and final volumes to calculate, to find out volume of AQUEOUS aqueous sodium hydroxide sodium hydroxide. Uh, Find out volume of aqueous sodium hydroxide required to neutralize lime juice. Stop. Now you and I both know, we have studied and we have discussed that titration sometimes gives us errors, right? It gives us wrong results. So what do we do to eliminate those wrong results? No, on one titration we do not believe. We are going to repeat this titration to achieve concordant results and take their average. All right. So repeat this titration with same lime juice, to achieve concordant results, and then find their and then find their AVERAGE average. Find their average. Full stop. Next, now repeat the experiment. Now repeat the experiment with lemon juice multiple times. With same volume of lemon juice. Full stop. All right. Now, after you've repeated the experiment multiple times, now you know how much volume was required to neutralize lime juice and how much volume of sodium hydroxide was required to neutralize lemon juice. So now you just finally conclude this. We say conclude the experiment by determining which juice is more concentrated. I dot E, the juice which required greater volume of dilute aqueous sodium hydroxide. Full stop. And with that, this experiment planning wala question has been completed, and so has been this past paper. Do you guys have any problems? Is everything understood?
Yes, sir.
Yes, sir.